My name is Haidrey. Once again, I'm here with my teammates Dinghang and Yulei, and we're here to present to you on a project we've been working on for the last uh, 6 months called Spinner, which is our next generation workflow engine here at Pinterest. Oh, sorry. So just to give an agenda, we want to tell you why we decided to move to Airflow, and then how we sort of went about onboarding and figuring out which open source project or internal project will work best for us to bring it to a production level ramp up. And lastly, we'll just want to talk about some issues we encounter along the way and what our next steps are. So we'll begin with talking about why we're doing this. So we're going to talk about addressing some of the pain points in our current existing framework and how we need to get to industry standards on some of the pain points that we've felt. So before we started working on Spinner, the internal structure was using a framework called Pinball. And so Pinball was our old scheduler system, and it's been running for about 5 years, actually more than that, uh, with numerous different patches and still serving our production workflow execution engine overall. But during the years of the basically development for this, we've learned that the data needs at Pinterest have grown exponentially, and that the old framework cannot necessarily keep up. So the old framework was not designed for scale of this magnitude. And so we saw a lot of basically performance and scaling issues. And the biggest ones that we saw at first were basically just scheduler delays. So the latency to actually start a workflow when it's supposed to be running, the latency between different jobs being picked up by the scheduler, things of that sort. And so obviously there was basically a lot of work to be done on the old existing kind of framework, where we were hitting a lot of different performance issues. And so we basically had to, for example, shard the clusters to make sure that we still meet the performance necessities for our production needs. And so we would have multiple different clusters set up to address the scaling. But the maintenance of multiple clusters was extreme high cost to us. Just to give some examples, one of the biggest pain points was basically migrating up to a newer version of Ubuntu on the different boxes. And we were just hoping to basically bring that all into a single cluster and make it a little bit easier for us to handle. Outside of that, we also have things such as feature requests that basically we didn't have the bandwidth to work on at the time, or even prior to any of us being on the team didn't have time to work on. So those basically aggregated into tech debt. And there's simple features such as general ACL, auditing, execution stats, aggregation, and like virtualization. And with that being said, it just seemed like it was very difficult to maintain the old system. And the last thing we want to mention is just that with all the different engineers working on this, it was not a very well documented system. It's actually quite difficult to understand the code when you're reading through it, and being able to just jump in and help. And so this deep learning curve made it hard for user support, for users to explain to them how to use the system, as well as our own team trying to develop and maintain the system. Uh, so with that, even just continuing with that, we were trying to find some sort of answers to some of these different pain points. And so the main thing is just that the fundamental design of Pinball was not meant for sort of this kind of scale. And so we had to make a decision. Either we could try to fix the existing framework and try to make it a lot more scalable. We could either try to spend time to build a new internal tool, or we should look at open source projects and see how we can incorporate them into our own, basically, general tech stack. And so after we did some research, we saw that, to be fair, I'm also very biased because I used Airflow at a previous company, and I really enjoyed it. So I was honestly pushing for this myself a lot. But just the fact that Airflow has a lot of the sort of features that we knew we needed to support our users' cases, it has a well documented open source community, it has a really high adoption framework. We had a couple of show and tells with Uber, Lyft, and Airbnb to learn a little bit more about sort of what they've been working on and how they use Airflow to meet their production needs. We decided that this is actually the step forward that we will take. And uh, given all that, uh, I'm going to jump into why or how we started developing our sort of general POC cluster and how we productionalized it after that. So just to reiterate the scale that we sort of work with here at Pinterest, we have over 10 current pinball clusters. We have over 4,000 total workflow definitions defined that are scheduled. And we have those definitions result into 10,000 daily active sort of flow executions, which are equivalent to DAG runs. And that has over 38,000 daily job executions, which are the task instances. So we want to basically somehow reduce the clusters to just be one or two. And I should say while still maintaining the level of need that we have. So just to kind of go over how we set up our POC, we try to use the out-of-the-box Airflow, code base, and we did some patches and modifications, mostly to the executor side. So we first looked at the Kubernetes executor that's out of the box, but due to the fact that at Pinterest we have some specific internal logic, we had to basically break out and build our own version of a modified Kubernetes executor to be able to submit tasks to Kubernetes. And so we simulated many different performance tests and stress tests to kind of identify how the system can perform and learn the limitations and bottlenecks. So this was as small as running 300 scheduled DAGs with 25 tasks each or 5 tasks each, all the way up to 6,000 DAGs with 200 tasks each. So for us at first, it helped us identify a lot of interesting findings. So we were able to learn that the UI performs well regardless of sort of the scale. It will respond fast enough, and luckily we could horizontally scale and bring up more boxes if we need to. But that was really a good indicator for us. Secondly, we thought that the MySQL side will be where things would actually fail over. We thought that was going to be the biggest bottleneck, but it turned out not to be necessarily true. And so it actually turned out to be that it was a Kubernetes submission, and the result of it was the parsing when a single scheduler is under extreme load. So the out-of-the-box Airflow has only a single scheduler, as you all know. And for that case, we learned that if we want the scheduler to kind of meet the performance standards that we have, we would have to keep that under 1,000 DAGs. After 1,000 DAGs, the scheduler performance decreases quite a bit. So just to kind of reiterate on this, that kind of helped us learn that, okay, well, if we could make some changes to the scheduler and make this horizontally basically scalable, then we'll be able to meet our guidelines of what we expect out of a workflow system. So multi-scheduler was a must for us to exceed the 1,000 DAG limit. And just again to give you a full picture of how our structure is set up, I just want to discuss again the findings from the performance test. So we learned that this single cluster-based solution is actually possible, and that's if we make sure that we could have the schedulers be scalable. And so we have a centralized place for users to manage their DAGs, and that will reduce some of the maintenance costs compared to how it currently was set up for us. And then if we have them basically different schedulers reading from different areas of this monorepo, we don't need to shard out different clusters. We could just have it all be within a single cluster. And if we make the Kubernetes executor improvements that we needed, we could basically make sure that all DAGs run in a quick enough fashion for us to say it's acceptable. So it's nice that we also get the features out of it, and we also will provide basically users uh, uh, a migration plan so that they don't have to do any work, and that we could just pick up the work from the old systems to the new system. Um, Again, that's because our old system's in Python and our new one's in Python, so we could do some workarounds to make the transition very smooth. And we'll talk more about this in future slides. With that being said, I'm going to hand it off to Dinghang, and he's kind of going to discuss some of the onboarding to Kubernetes that he worked on.
Sounds good. Thanks, Ace. Hi, everyone. I'm Dinghang from Pinterest, and I'm going to talk about something related to Kubernetes. So this is the architecture picture for Spinner, which is the customized Airflow to interact with our Kubernetes cluster. From the left side, you can see, so every Spinner would have a scheduler, and for us, we have multiple schedulers. So each scheduler will have some tasks to do, and it will send those tasks to the Kubernetes executor. And the Kubernetes executor has its own scheduler. It will try to submit it to Kubernetes cluster via GSS. GSS is Job Submission Service, which is Pinterest's specific service. And then from the Kubernetes side, every pod will be started to run the task. And some of the tasks, they will submit it to Monarch, which is our in-house Hadoop system. And all those Hadoop jobs, MapReduce jobs, Hive jobs will be running on Monarch. And here, as you can see, some of those pods will spin off a new pod. That's for our migrate case, because for our migrate case, the older system is using a different DSL. So in this case, we probably cannot run the job in the same pod. So that's why we start a new pod to mitigate this issue, to help user quickly migrate their jobs and workflows from the older system to the new system. And here, because of the setup at Pinterest for Kubernetes cluster is totally different, so we have to rewrite all those Kubernetes APIs to interact with Pinterest in-house Kubernetes setup. And also, we tried our best to return the basic business logic from the open source Kubernetes executor. So in case later on, if there's some updates, we can always update from our side as well. And the good thing to use Kubernetes executor is like we evaluated several executors. Then finally, we decided to use the Kubernetes executor to resolve all those pain points Ace already shared before, like performance issue. So by using Kubernetes executor, we can always easily scale up and scale down, and there will be less scheduling delay for us. And also, it's better isolation. So each task will run in their own pod, and they won't affect each other. It's not like a prim host before. Like several tasks can be running on the same host using the shared resource. And if one task went bad, it can affect other tasks as well. But by using Kubernetes, that issue is gone. And also pod shared Kubernetes nodes with other services. And our Kubernetes team provides so many nodes, so we have a lot of resources to share with the whole team. And those pods will get removed right away after the task execution. It's really easy to maintain. And to support the pod scenario, we rebuild the Kubernetes operator. In this case, user can bring their own image to execute jobs for specific reasons. So after the architecture, let's take a look at the sequential diagram of the Kubernetes executor. As you can see, there are three blue boxes. Those are the components in the Kubernetes executor. It's Kubernetes executor itself, Kubernetes scheduler, and the Kubernetes job watcher. And the green box is the Kubernetes cluster. And there are three queues: tasks queue, results queue, virtual task queue. Those three queues are used as bridges for communicating, for those three components to communicate with each other. And every time there's a new task, the Kubernetes scheduler will pull the task and send it to the Kubernetes cluster. And then when the pod is running or finished, the Kubernetes job watcher will try to fetch the pod status from the Kubernetes cluster. If it's finished, it will try to process it and put it into the virtual tasks queue. And later on, the Kubernetes executor will try to fetch it from the virtual queue and do some process, put it in the result queue. And then the Kubernetes executor finally will fetch all those items from the result queue to do the final processing. So that's the way how Kubernetes executor is work. And to achieve this, we have to rebuild the Kubernetes pod status polling mechanism for the same reason. At Pinterest, we're using a different Kubernetes setup. So we have to create our own watcher to pull all those pod status. And the good thing is like we use labels to isolate the pods started by different schedulers. As we are using different schedulers to start different tasks, every time the watcher just want to fetch all those pods started by its own scheduler, not others. So that will be easier for our executor to process with. And also we did some pod customization. So we combined the DAC ID, task ID, execution date, try number info to create a meaningful pod name. So based on the pod name, we can already get the simple idea what task it is running right now. And also we provide a pod customization. So if the user want to use different pod environment, different images, different resources, or install different packages, they can always configure that in the operator itself. And for using pod, it's different from the on-prem host where everything is set up. For pod, every time we start a new pod and new container, in this case, we have to make sure some general services like S3, MySQL are always available for the pod before they run the task command. So to do that, we have to do some pod readiness check. That's something we didn't do in the old system, but we have to do in the new system. And we've already achieved that. It's working very stably right now. And also we rebuilt the log polling mechanism. So the logs will be uploaded to S3 after the task completion. But during runtime, those logs won't be uploaded to S3. So we get those logs synced to Pinterest Elasticsearch, and the UI will pull runtime logs from the pod or Pinterest Elasticsearch. This is working well for the pod if they failed, like before we run the task command. So let's say if there's some readiness check failed or the pod startup failed, user can still get the logs from the UI and see what's going on. So to achieve that, we also redefined the CICD pipeline. And basically, we separate the repository for infra codes and user codes. The good thing to separate that is like right now, users can do 24/7 deployment based on their own needs. And we only need to do infra-related deployment whenever it's needed. It's not like the older system. Everything is combined together into one repository. And users also have to deploy their codes based on our own deployment. So that's something users were kind of complaining a lot. Now they can, everything is on their own, so they can always check in the code by their own needs. And from the left side, you can see there are three lines. The first line is the spinner report, which is our infra code. Every time there's a new changes come to the code, it will trigger Jenkins job to do some basic unit tests and then publish the new image to the registry. And then we will use the same image for the web server and the scheduler hosts. And also the Kubernetes pods will use the same image as the scheduler to make sure it's consistent. And from the right-hand side, every time this is the user DAG report. Every time user check in some new DAGs or do some modification for the DAGs, those changes will be synced to S3. And there's some process running on those hosts. Like it will sync all those DAGs from S3 in a very short interval, like 30 seconds, every 30 seconds. And the worker pod will also sync the latest DAG from S3. And in the middle, this is the pipeline for our older system, because we are also supporting the migrate case, which will require another image for the migrate case for the older system. So we're also including that. here in the CI/CD pipeline. And for security reason, we also enforce the DAC level access control. So access control field is a mandatory field. Every user have to provide this information. By default, it's assigned to the user who created them or the role they belong to. So in this case, all those information, DAC access information is synced to DB when the DAC is passed by the scheduler. And users can only see the DACs created by them or only by them. Also, the access can be only granted like to the role like user is assigned, which means user can only edit or trigger new DAC if the DAC belongs to them. And we also have action auditing right now. That's a good feature compared to the old system. And the backfill is always a feature user want to do. And for sure, user can use some client to do the backfill for their jobs. But we feel like it will be easier for user to do everything from the UI. So we'll create a backfill page for UI for users, and users can just choose the DAC and type in the execution dates and just click. It will automatically run the backfill jobs for them. So users don't need to do anything from the command. And also, we still apply the DAC level access control from the UI for the backfill. So which means user can only backfill those DACs belong to them. Lastly, we also have some good features in the old system, but not in Airflow, like the task instance table and also the DAC run history view. And our user loved that, so we think we moved it to Airflow. I mean, we integrated the new feature in the Airflow, and it turned out to be really good to show them up on the UI, and the user can have a different aspect about how the DAC is running and how the task instance is going on. That's pretty much from my side. And next, Yulei will talk about some cool features in Airflow in our spinner. Thanks.
Thanks, Dinghang. Hi, everyone. My name is Yulei, and next I will talk a little bit about some of the new features that we built on top of Airflow. And also we'll do a wrap-up session to give an overview of where we are at and what's our next steps. So first is our multi-scheduler setup. So our design for the spinner system at the beginning is to have one cluster, as Ace just mentioned, with one UI interface where user can see all the DACs. So our goal is to avoid the maintenance overhead and confusion with multi-cluster and UI entrance as we had for the old workflow system. However, consider the scale we have, it is not feasible to have only one scheduler to manage all the DACs. Also, the vertical scaling, such as increasing the DAC parsing parallelism, is not a long-term solution. So we go with the route to have multiple scheduler, where each scheduler looks at different DAC partitions. So to make this possible, we modify the scheduler implementation. As the out-of-box Airflow scheduler is stateful, and it is not feasible to run more scheduler instances to address performance concern without interfering with each other. So instead, we implemented a role-based partitioner to tag a given DAC to a specific partition, and assign each partition to one scheduler to manage. So in that way, each scheduler will only parse, dispatch, and maintain status for the DACs it owns. So two scheduler nodes will not interfere with each other. And on the other hand, the UI module will render all the DACs despite the partition, so that we will have a single entrance for the users. But the UI will still honor the partition tag in the task instances and make sure if the task instances is reset or got triggered from the UI, it can be dispatched with the partition tag so that the instance can be picked up by the corresponding scheduler for execution. And in addition, with this multi-scheduler setup, we can also fulfill a long-time user ask to support tiering, where workflows with high priority will be put into dedicated scheduler partition, and we set the limits on the maximum number of DACs the partition can have. So this way, we can guarantee that more strict scheduling SLA for higher priority flows. And in terms of user testing, to make it easy for the user to test out their DACs, we provide a script to launch a container on their local machine, which runs the Airflow scheduler and web server processes just to mimic the production environment. This local testing environment uses a local MySQL database and local executor to run tasks, and user just need to put the DAC file under a specific folder on their machine, which will then be discovered by this local scheduler, and user can view their DACs on the local UI directly. Another use cases we supported in Pinterest is to migrate workflows from old system, which is called Pinball, to Spinner with minimal user code changes, as Ace mentioned at the beginning. However, it is not feasible to directly translate Pinball workflow definitions to Airflow DSL due to all the customized user logic and dependencies put in the Pinball jobs. Which means for those migrated workflows, we will not have a regular DAC files where DAC object and tasks are defined. Instead, we add a layer on top of the Airflow scheduler to extract the flow layout and job specification from the existing Pinball workflows and rebuild them into the Airflow DAC and operators on the fly. This customized scheduler is still file-based, but instead of parsing a regular DAC file, it understands a customized metadata file which denotes how to locate migrated workflows. This is possible because we think essentially a DAC file is just an identifier of one or more DACs. It just happens to be the case that the DAC file in the native Airflow implementation contains the definition of a DAC. But it is completely possible that the DAC file can point into somewhere else where the DAC definition is actually defined, as long as the scheduler module is able to interpret it. And in addition, we utilize DAC serialization feature in both the UI and worker to support rendering and executing tasks for these migrated workflows without DAC files. And to ease the process of the workflow migration, we also built a UI tool to enable user to migrate workflows. So just in a few button clicks, as you can see in the left graph, a workflow can be unscheduled from the old workflow system and be migrated to Spinner. We also support rollback of the workflow migrations through the migration tool. So if anything went wrong for the migration, user can roll it back directly with this UI tool. So the workflow will be then unscheduled from Spinner and then rescheduled to the old workflow systems. And to close up the session, I would like to give a quick wrap up of where we are at and what's our next steps. So we GA'd Spinner in late 2019 with Airflow forked from 1.10 stable, and we cherry-picked the serialized DAC feature to use in the migration case. So in production, we have two environments for the PII and the non-PII use cases, and PII stands for personal identification information. So each of these two environments has 2 web servers and 6 schedulers to cope with load we have at Pinterest. And we run the Spinner workflows on top of the, we run the Spinner workers on top of the Kubernetes infrastructure. And in terms of the system migration, it is still an ongoing effort, but we have successfully migrated more than 800 flows from the old system to Spinner since we supported the migration feature on Spinner. And also, we are working with different teams and orgs to help them onboarding to Spinner. And to support various use cases, we implemented around 30 new operators and helped onboard more than 80 new workflows to Spinner. And so far, we have around 600 internal users already registered to the platform. And as to the next step, we have a lot of items on our roadmap to add new features and make improvements to the Spinner systems. And one of them is to add the DAC versioning support into the system. So this is to support use cases where DAC layout is generated dynamically, and may vary between scheduler processing. We call this kind of DAC as dynamic DAC. For example, if the DAC layout is generated based on the status of some external services or data, the layout loaded from the DAC file may vary, depends on the time when the DAC file is parsed. So this is not supported by Airflow out of box. And with the native implementation, it might have potential issues such as when the worker tries to execute tasks from a DAC run, but the DAC layout it retrieves from the DAC file differs than the layout when the DAC run was created. So the worker might not be able to get the particular task from the DAC and thus errored out. So we have this use case in Pinterest, and it is supported by our old workflow system. Thus, we are also building this feature on top of Airflow. So it is still a work in progress, but the basic idea is that we want to bind each DAC run with a specific DAC layout generated when the DAC run is created. So that when a task from a particular DAC run is needed, the system will be able to retrieve the task from the particular DAC layout instead of loading it from the DAC file directly. So we have modified the major components, such as the scheduler, web server, and worker to support this DAC versioning feature. And the flow chart on the left shows a high-level views of differences of the scheduler processing logic with and without this new DAC versioning feature in our design. So in the new design, two major changes for the scheduler modules are first, the DAC layout will be regenerated during the DAC run creation time and will be serialized. So a newly created DAC run will always be bound to the latest DAC layout. And second, whenever a DAC layout or of a specific version is needed in the scheduler processing, such as to verify the DAC integrity or to schedule task instances, the system will load and deserialize the DAC layout. So in this way, we can make sure the correct version of the DAC is always used. And in addition, we are also doing a lot of the usability works to provide better user experience with the spinner system. And here are some of the major ones. So first, we are in the progress of implementing an IDE plugin, which allows users to compose DAC based on some predefined templates to help them write DAC faster. And second, we are building more operators to cover more use cases. And also, we are porting over some of the features from the old workflow system, which are loved by our users, to Spinner to facilitate the user onboarding. And also in Pinterest, we have various other systems that depends on the workflow system, the workflow engine. But those systems are still integrated with the old workflow system. So we will be working with the teams to help them onboard to the Spinner as well. And last but not least, we also would like to contribute back some of the works that we have done and are doing in Pinterest to help the community as well. And with that being said, this is all we have for today's session. And we will get to the Q&A session. Feel free to ask any questions you have. And thanks for listening.
All right. Wow. Let's give a big thank you to our presenters. If we clap loud enough, I think that they will hear us. And I am going to give a few seconds for the questions to populate in our chat. I do know that one of the questions that showed up in Slack was if it was possible for these slides to be made available for folks.
I think it would be possible, but we probably would need to check with the internal legal team first. But yeah, we will update the Slack channel when we get any response from the legal team.
Great, thank you. Okay, next question. Enforce DLAC, can you talk more about how you do it?
So every time when user use the UI, they have to log in. Once they log in, they have already registered from the Spinner system, and we already have their information. And we also have those roles which contains many users. And every DAC, it has the role associated with it for those operators and the DAC itself, which means we will do a match. If the user is not in the role, then that user won't be able to see that DAC, and they won't be able to do any operations on the DAC.
Okay, thank you. All right, we have someone who's curious to hear more about testing. For example, can the user access production data to run the DAGs in the test environment?
No. From the test environment, they cannot run the data against the product, but they have their own kind of version of Airflow on their kind of box. So they can try that out from their own local host first. And if you think that's okay, then they can check in. So the DAG will be running on the product. And since we have 24/7 deployment for user codes, they can always make a quick fix or make some changes and deploy it again in like 30 seconds. That will be there.
And to add to that, we also, for all the local running jobs, those jobs can only be submitted to the ad hoc cluster for execution. So those local testing jobs will not interfere with any production job in terms of execution.
Awesome. All right, next question. How did you manage dependencies between tasks in Pinball and Airflow during the migration process?
So yeah, that's a really good question. So in Pinterest, the dependency is managed by a centralized table we call batch table. So if there's a cross workflow dependencies, the dependency is enforced by checking the record on that batch table, which means when there's a workflow success or the job success event, there will be a success entry got recorded in the batch table. So in that way, even we have like workflows in Pinball and workflows in Spinner, the Spinner side workflows will still be able to check the like the job success event from the job execution on Pinball side.
Right.
So it's really like a data-driven dependency check.
Right. To add some information here, so we also created several sensors. So those sensors can help detect the dependency across different clusters, across different systems.
Cool. Thank you. Okay, next question. Folks want to know what the main use cases are for Airflow for you. Are you using complex or simple DAGs?
Yeah, I can go first. I think our use cases is very, very broad. For example, like I just mentioned that we have other system depends on the workflow system. For example, we have like machine learning model training system that will have their own composer. But once the job are composed, they will inject those jobs into the workflow system. Those jobs are kind of like those composed that are kind of complex because those are model training jobs and have many jobs. We also have like simple DACs which only have like several jobs. So it really depends on how the user want to use the system, but we provide all options. So we don't like have limitation on whether you can only write like put this many DAC jobs in a DAC.
Okay, next question. For dynamic DAG creation, how different is it from using variables that were updated from a previous task run and then using subDAGs to create the subsequent DAGs?
That is an interesting one. So we haven't explored the route with subDAG, but I think a problem is that when the user, for example, want to backfill a previous DAG run or want to rerun a previous DAG run, they want to run the DAG layout of that specific snapshot, which means if the DAG layout is still parsed from file and use some variables, the DAG layout will still change. So which means when you want to rerun a previous snapshot, the DAG layout might already change. So you will not get the same layout as when the previous DAG run was executed. So that's something we want to address, and that's something we supported in the old workflow system. So the user can, like, for example, rerun a previous snapshot of the DAG layout. They can do that. So that's something we want to address. I think that's probably not available, not feasible through the sub-DAG approach. As long as the DAG layout is parsed from the file, whenever the system need it, it will still like have differences in the layout. It will like the layout will be regenerated, and it's not necessarily the same layout as when the DAG run was created.
Okay. Another question that we have, what is the size of your team and your organization? And they say build and run.
So the size of our like small team for the workflow system, we have like around four full-time employees working on the backend and UI side, and we also have 3 contracts for like answering those questions, user question to do user support, and 1 SRE.
Cool. All right, we have one more question that came in. Just kidding, two. Someone says, I might have missed this in the presentation. Which of these features do you plan to push to Airflow open source?
So we actually have a couple of the new feature, but if you are referring to the DAC versioning feature, we do want to productionize the DAC versioning feature in Pinterest first. We are still in the progress of implementing and productionize it. And after we productionize it and make sure it runs smoothly, we will start like communicate with the community to see when will be a good timeline and what will be the good process to commit this back. We do know that this is not a small change; it involves quite a lot of a lot of changes. So we will need to work with the community closely to make sure we can get this feature like back to the upstream.
Sounds like people should watch that dev list. Okay, next question. For composing DAGs for non-technical users, will it be a YAML-based solution?
So right now we don't have the YAML-based solution. Basically, users will just create some Python file, which is a DAG file as well. And Airflow has a lot of documentation, so it won't be that kind of hard to create a new DAG file. And also, we are working on something to auto-generate those DAGs for users, which means we will provide some templates. And in this case, user can just check some like fields, and it will automatically create a DAG for user. So I guess that will be something similar as the YAML-based solution.
Yeah. Also, just one thing I want to add. So we also have a web-based or UI-based workflow composer called FlowHub at Pinterest. Right now, it is a standalone system, but I think we are thinking about integrating the FlowHub system with Airflow, which means with after the integration, so the non-technical background users will be able to compose that using that web-based composer directly and run it on Airflow. But that's something probably on the plan. We haven't start that progress or the conversation yet.
All right, we have another question. How are you dealing with DAG governance, like ownership and other things? And do you expire DAGs?
So first of all, we don't expire DAGs unless user delete them. And for the governance, we have the ownership like project. Each DAG will be assigned to a project, and that project is created by user for different teams. So based on the project, actually there's an internal service we can know which team this project belongs to. So that's how we deal with the ownership.